You are welcome back to Integral Exercises Mathematics. In this video, I hope to explain what does it mean by pi of x function. Right, most of the students they are misunderstanding and they are really confused with this limit. Limit upper a let upper a goes to infinity. The integral from 0 to a e to the power minus t times t to the power x, right, dt. This is known as the pi function. Let me simplify it according to highlight ethic. We may be able to apply this ethic, and then using integration by part, we can rewrite it limit let a tends to infinity minus times e to the power minus t upon minus that is just minus times t to the power x minus integral from 0 to this is from 0 to upper a, right? From 0 to upper a e to the power minus t upon minus 1 d t to the power x. You know that it's too difficult to integrate e to the power minus t with respect to t to the power x, so therefore we can simply say internally differentiate t to the power x with respect to t and alternatively integrate that. Right, okay, I'm gonna break them into two pieces once again. Let me focus on this one, right? So let me do it distinctly. You know that the expansion of e to the power minus t here, we can rewrite it as 1 upon e to the power t, right? 1 upon e to the power t, you know, it comes up with 1 plus t upon n to the power n. Our limit n goes to infinity, but I'm not gonna write down all of them, but we can interpret it simply t to the power x upon e to the power t. What is e to the power t? 1 plus t upon factorial 1 plus t squared upon factorial 2. Likewise, it tends to infinity, right? Okay, please I'm really sorry that in advance I forgot to introduce you. X is an real element, is an element of a real number set, and it's not going to be equal to infinity, right? We don't define it for infinity, so non-infinite, this is a finite value. This you can imagine for 3, 4, 5, 6 like that. So what happens, you can take out this t to the power x out, then you may be able to cancel out this discontinuous point, right? Once you take out this discontinuous point, I have shown you this in my previous videos, right? If you don't have any idea about discontinuous point, please go there and try to get an idea there, right? Okay, that's very compulsory to know, because without knowing those things, it's not good enough to go through in limits, right, and calculus. Therefore, then this is what, 1 minus x, then you know that's an then you know sorry, this is directly t to the power minus x, right? I'm really sorry. This should be t to the power minus x, t to the power minus x, plus this is t to the power this is 1 t to the power 1 minus x, right? Likewise, 1 upon factorial 1. Likewise, you can write down it continuously, right? Then you can cancel out this, because this limit can be taken inside, right? Sorry, really sorry, t should be replaced with upper a, because we need to apply these boundaries, right? This boundary, this limit can be substituted on this function what we have integrated, right? So then you can cancel out this a to the power x as a discontinuous point, then let a approach to infinity. Then you can realize that once a approach to infinity, these are going to be these are going to be, some of them will be after a particular boundary, you can see all of them are going to be equal to 0, 0, 0 plus 0 plus 0, right? So then it tends to here this one e to the power minus x, x is a real element and is a positive real element, finite positive real elements. For that, e to the power minus x, once x approaches to once e approaches to infinity to the power this much, right? So 0 plus 0 plus 0, those are going to be equal to infinity plus infinity plus infinity. Then after that, 0 plus 0 plus, then in your numerator you can see infinity, 1 upon infinity, all of them tends to 0. I have explained you only, right? Then and also you can do it using following up these explanations. Let me go for the next slide. Right, okay, so we were talking about that integral once limit approach to infinity, we could write down that is just 0, right? It was neglected there. After that, the next integral from 0 to a, it became minus times minus, it becomes positive, right? Then what happened at rest t to the power minus t, we have differentiated that x times t to the power x minus 1, right? With respect to t, right? You could see that pi of x was that previous function. If that was my previous function, this can be named as pi of x minus 1, right? Okay, then you can see it recurs, right? It recurs up to x times x minus 1 times x minus 2 times, likewise x minus 1 times it recurs, including this first one, x times it recurs, because x minus 0 times x minus 1 times, likewise x minus 1 times, right? Logically try to construct these logics, right? Gradually you can construct these logics, and if you feel like it's too difficult to get these logics, construct these logics gradually, you can keep doing it with 3 for very minor value, right? Okay, and the rest you can see from 0 to infinity. Once you substitute that limit from 0 to infinity, e to the power minus t times t to the power 0 dt, right? So this is just 1, right? So what is pi of x? Pi of x is x times x minus 1 times x minus 2 times, likewise it goes to c1, right? Okay, so what is this? Let me conclude that this is factorial x, right? Then once x equals to 0, pi of 0 is just factorial 0. You can work with this origin, right? As from origin, that is nothing else, this one, right? So that's going to be equal to 1, right? Okay, and also at rest I have shown you guys factorial 0 is going to be equal to 1, right? As an LLD student, you should be able to do this, right? Okay, thank you for watching. I'm Sapuman Sinali Sasank Sagar.